Alright, so this is my lab one for charged tapes. The purpose of this lab was to study the interactions between two charged objects, specifically two pieces of tape. And in doing so, we wanted to find the charge on the tape and the corresponding number of electrons and whether it was in excess or deficiency. And we wanted to compare our calculations with a simulation through Glowscript. And we found that the two pieces of tape were repelled by each other because they were both positively charged, and the electric charge on one tape is 1.4 times 10 to the negative 8 coulombs, and the number of deficient electrons is 8.74 times 10 to the 10 electrons. So some key concepts that were relevant in this lab were Newton's second law, and from that, F equals mg, which is the force of gravity due to Earth, and this describes the weight of an object, and in this case, the tape. And using that, we were able to get the electric force of an object, which describes the electrostatic interaction between two charges, where Ke is Coulomb's constant, and we use that to find the charge on the tape since Fg and Fe, when in static equilibrium, are equal to each other. So from the observed model, you can see our setup on the right. It has two stands and the floating tape on top, and we used a separate piece of tape to get it to float. And the initial conditions were that the length of the tape is 0.2 meters, width 0.02 meters, mass 2 times 10 to the negative 4 kilograms. We got the area of the tape and the atom area as well, and the number of atoms, which we found to be 4 times 10 to the 17 atoms. Alright, so on the left you can see a video of the tape floating very briefly for a second. The system is the floating tape, the surroundings are the held tape, two stands, and the Earth. The separation distance was found to be 0.03 meters, and if you look very closely, as the held tape gets closer to the suspended tape, sorry, it's not playing. All right, as the held tape gets closer to the suspended tape begins to levitate very briefly. So what's happening here? We provided a charge to the held tape by removing it from another piece of tape, and this caused the bottom tape to have charge, and when brought close to the tape, we can see the interactions. The force of gravity acts down, but the electric force acts upward. So the two tapes were repelled by each other when they were moved together, so they have the same charge. And we found that this charge was to be positive because we not only did we rip the tape off another piece of tape, but we ripped it off a pen, and the pen was negatively charged after gaining electrons from being rubbed against the hair, which means that if they were attracted to one another, the tape would be positively charged. And we assumed that both pieces of tape were to be point charges rather than a line of charge, and each tape would have the same amount of charge, even though this wasn't exactly the case, and any air resistance or friction is ignored. And on the right, you can see the upwards force, electric force, and the downwards gravitational force. So we did the calculations. Force of gravity and electric force are equal to one another, both 1.96 times 10 to the negative 3 newtons. Found the charge and the deficient electrons, which were these numbers right here. So I made a computational model. On the left, you can see the 2 point charges, which are supposed to act as the tape, the blue being the floating tape and the red being the held tape. And we see the electric force pointing upwards, gravitational pointing downwards. On the right, you can see the code written for this function. We have our constants, E field function, and the calculation to find the charge on the tape, as well as the number of electrons, deficient electrons, and ratio of atoms to deficient electrons. And here you can see the setup for the visualization. We have the spheres and the arrows and the vectors. So the results of the computational model support the calculations in the previous slides, and that there should be a loss of electrons since the tape is positively charged. So some possible sources of error were that the separation distance were not accurately measured, and some charge may have been lost in the environment, or any other forces were not accounted for. So what if the electrons had positive charge and the protons had negative charge? Like, what happened if they were flipped? Ultimately, the observations would not change because the two pieces of tape would be negatively charged and thus still repel each other, but have excess electrons instead of deficient, and they would be attracted to the instead positively charged pen. And it is important to handle the tapes as little as possible because the charge will become neutralized when coming into contact with hands or other objects. And the tape would try to gain electrons, so it would become less positive when being held, and thus no electrostatic interaction would occur. Thank you.